Introduction to Human Nutrition is the first of many videos covering human nutrition. This video will cover introduction and definitions of terms, categories of nutrients, demand for different nutrients, evolution of the science of human nutrition, and factors that influence the availability of food on a global and local scale. So let's start with the introduction. Plants, animals and humans. That means all living things or anything live requires nutrition. Why? For what purpose? They all need nutrition to survive, to grow and maintain the body and its functionalities, and to stay healthy. These are the basic functions, or fundamental roles that nutrition plays. Plant nutrition is the subject of agriculturalists and that of animals belongs to veterinarians. We will only talk about human nutrition here. The definition of nutrition will be discussed next. I have shown here two definitions of nutrition. First is, the process by which living things receive food to survive, grow, and be healthy. The second is, nutrition deals with, providing essential nutrients in food necessary to support life and good health. Basically, we take them as food but the body absorbs them as nutrients. There are three main categories of nutrients. They are, macronutrients, which include carbohydrates, protein, and fat. They are referred to as macro because the body needs them in comparatively high quantities, measured in grams. The second category is micronutrients and they are needed in small quantities, such as milligrams or even micrograms. Vitamins and minerals fall under this category. The third category, which includes water and fiber, is classified as other. Protein is necessary for tissue growth and repair, whereas fat and carbohydrates give the body the energy it needs to function. Minerals and vitamins support a number of body processes that will be covered in another video. While water is essential for survival, fiber serves as a prebiotic, that is, food for beneficial bacteria in the gut, and aids in bowel regulation as well. For the sake of completeness, I've included a list of different vitamins and minerals that are essential for bodily functions. They are Vitamin A, Vitamin B, Vitamin C, Vitamin D, Vitamin E and Vitamin K. Vitamin B is a complex consisting of B1, B2, B3, B5, B6, B7, B9 and B12. Among the many minerals, iron, calcium, sodium, potassium, magnesium, zinc, and copper play important functions in the body. These details will be covered in another video. I will now talk about the demand for nutrients. Nutrients are not required equally throughout the life. Different nutrients in varied amounts are required for various ages, circumstances, and conditions. For instance, small children need more protein to grow, whereas young children need more energy as they are very active. Young females need more iron as they lose blood in menstruation while older people need more calcium and vitamin D to maintain healthy bones. Different situations in life require different nutrients in varied amounts. For example, pregnant mothers need more protein, iron, and folic acid for the baby to grow, to produce blood, and to prevent certain disease conditions. Lactating or breastfeeding mothers need more protein and calcium to produce milk. Because they engage in physical activity, athletes require extra energy. Bodybuilders need more protein for the growth and maintenance of muscles. Similarly, different diseases and conditions need varied nutritional requirements and even some restrictions. Diabetics should not take too much carbohydrates, patients with hypertension should limit their salt and fats, and those having certain liver diseases should restrict the intake of protein. During the convalescence phase following illness or surgery, patients require additional protein and vitamin C to support tissue growth. Some specific nutrients are needed to treat certain nutritional deficiency conditions such as kwashiorkor, marasmus, and anemia. Hence, diverse situations and conditions require special nutritional interventions to successfully manage them. As I described earlier, there are three types of nutrients: macronutrients, micronutrients and other. Nutritional science is all about when to provide what, how much, and how long, or when not to provide them. You need to learn all these combinations during the study of human nutrition. Next, let's look at the history of nutritional science. How nutritional science evolved. Our predecessors were hunter-gatherers, before 4000 BC. They made their living by collecting food from naturally available sources in the area, such as wild edible plants, birds, insects, honey, eggs, and anything else that was safe to consume. They were omnivorous, that means consumed foods of both plant and animal origin. Food was received not by choice but by chance. So they did not have the choice to select their food but consumed whatever found when hunting. Although farming began after 4000 BC, it was first restricted to crops that were readily accessible locally. The diet in the tropics tended to depend heavily on plant foods, while the diet at higher latitudes tended more towards animal products. The choice was taste, not nutrition. Discovery of nutrients was observed during the 16th and 17th centuries. Antoine Laurent Lavoisier, regarded as the founder of chemistry and nutrition, made significant discoveries about nutrients. In 1770, he discovered metabolism and demonstrated that energy from food is derived from its oxidation. In 1840, Justus Liebig of Germany was the first to describe carbohydrates, fats, proteins, and later minerals as nutrients. In 1912, a Polish physician, Casimir Funk, first used the term vitamins as essential factors in the diet. The term vitamin, first called vitamin, comes from vital and amine. Later on, different vitamins were discovered as follows. Vitamin B1 and C in 1926. Vitamin D in 1931 and E in 1936. Vitamin A and K in 1939 and vitamin B12 in 1948. Lastly, we will look at the factors that influence food availability both locally and globally. Firstly, environmental factors. They are climate and weather, seasonal patterns, rainfall, temperature, and extreme events, droughts, floods, directly impact crop yields and livestock health. Soil quality. Fertile soil enhances agricultural productivity, while erosion or degradation reduces it. Availability of water. Access to fresh water for irrigation is critical, especially in dry regions. Natural disasters, earthquakes, hurricanes, and pests can devastate food production. Environmental sustainability. Overfarming, deforestation, and climate change threaten long-term food security. Secondly, economic factors. They are income and affordability. Poverty limits access to food even when it is physically available. Market systems. Efficient distribution and fair pricing mechanisms ensure food reaches consumers. Trade and globalization. Reliance on imports/exports affects availability, and trade barriers can disrupt supply. Labor and credit access. Availability of agricultural labor and farmers' access to loans influence production capacity. Third is political and institutional factors. They can manifest as government policies. Subsidies, tariffs, and agricultural investments shape production incentives. Political stability. Conflict or corruption disrupts supply chains and diverts resources from food systems. International aid. NGOs and foreign assistance provide relief for poorer nations. Fourth is technological and infrastructure factors. They are evident as farming techniques. Modern methods such as precision agriculture, GMOs boost yields. Infrastructure. Roads, refrigeration, and storage facilities reduce post-harvest losses. Energy access. Reliable energy supports irrigation, processing, and transportation. Fifth, social and cultural factors. They are population growth. Increased demand strains food resources. Cultural preferences. Dietary habits influence crop choices and agricultural priorities. Education and knowledge. Farmer training improves efficiency and innovation adoption. Sixth, health and biological factors. They consist of crop or livestock diseases. Outbreaks such as avian flu and wheat rust, reduce food production. Food safety, contamination or poor handling can render food unsafe or unusable. 7th. Logistical and systemic factors. They include, food waste. About 30% of global food is lost in supply chains or by consumers. Distribution equity. Uneven access within regions or households can cause localized scarcity. 8th and the last is, resource management issues. They can be observed as land use. Competition between agriculture, urbanization, and conservation affects production areas. Water management. Sustainable food production relies heavily on effective irrigation infrastructure and water usage strategies. What you learned in this session can be summarized as follows. All living things need nutrition to survive, grow, and be healthy. Nutrients are categorized as macro and micronutrients based on the amounts required by the body. Demand for nutrients differs with different stages of life, conditions, and situations. Nutrition science gradually developed over the 16th, 17th and 18th centuries. Food supply is influenced by a wide range of factors both globally and locally. Here are some additional videos on human nutrition available through this channel. If you find these videos helpful, you can subscribe and click the bell icon to receive notifications when new videos on various topics are posted on this channel. Thank you.